Dear students, now we are going to see the subject linear integrated circuit. The subject code is EC3451. Under that, the topic is analog to digital converters. On completion of this analog to digital converter, student will be able to explain the different types of analog to digital converters and summarize the operation of successive approximation type analog to digital converters. Analog to digital converters are the device which convert the analog input into a digital output. And the ADC has two addition lines, starts and EOC, that is end of conversion, to control the analog to digital conversions to start and stop the conversion. ADC is classified as direct type and integrating type. The general ADC consists of analog input, start and reference voltage, and the digital output is represented by D1 to Dn. There is the functional diagram of analog to digital converter. The direct type analog to digital converters compare the given input signal with the internal reference signal. It is classified as flash type, counter type, ramp type, or a single slope type ADC, successive approximation type ADC. Integrating a type ADC perform indirect conversion. Analog input signal, that is a function of time or frequency, is converted into a digital code. They are classified as a charge balancing ADC, dual slope ADC. Applications of ADC are data loggers, panel meters, and monitoring systems. Specifications of ADC: the range of input voltage, that is the voltage difference between the maximum applied input voltage to minimum applied input voltage, is known as the range of input voltage. Input impedance: the ratio of change of input voltage to change of input current is called input impedance. Accuracy: the measure of difference between the actual output voltage and expected output voltage is called accuracy. Conversion time: the time interval between the end of start signal and end of conversion is called conversion time. Quantization error or digitizing error: it is based on the resolution of the digital system. Increasing number of bits result a finer resolution and small quantization error. It is the difference between the time varying analog signal with an ADC to converting back to analog signal is called quantization error. QE is equal to VI into full scale reading divided by 2 power n minus 1 the whole square. Differential linearity: it is a measure of variation in voltage step size and causes the converter to change from one state to another. It is expressed as the average step size. Analog to digital resolution: resolution is defined as the change in input voltage required for a 1-bit change in output. So resolution is equal to full scale input voltage divided by 2 power n minus 1. Analog to digital conversion drift: drift of A to D converter is the quality of a circuit to change the parameter with time. Parallel comparator or a flash type A to D converter: it is the fastest and expansive technique. It contains a series connected resistive network, its operational amplifier and a decoder. The operational amplifier is operated as a comparator. In the comparator, if the input voltage is greater than or equal to the reference, the output of the comparator is 1. If the input is less than or equal to the reference, the output of the comparator is 0. The analog signal applied to the input terminal VA to be converted into digital signal. The input signal is directly applied to the non-inverting input terminal of all the comparator. The resistive network will develop a different reference voltages. The applied input voltage VA is compared simultaneously with reference voltage using comparator. A 7-bit output is obtained from the comparators. So this is a flash type A to D converter circuit diagram. The output of the comparator is given back to the 3-line encoder, decoder. The decoder output is the digital output. A 7-bit output is converted into 3-bit output using a 3-line decoder. The comparator output and a 3-bit digital output for each value of analog voltage is given in the table. The number of comparators required for n-bit resolution is, number of comparators is 2 power n minus 1. So this table detailedly describes the different voltage level and its different output, digital output. Advantages: apart from high-speed operation, the conversion takes place simultaneously rather than sequentially. Conversion time is less. Disadvantages: for each added bit, the size of the comparator should be doubled. For n bit 2 power n minus 1, comparators are required. The design becomes complex for higher bit output. So successive approximation type A to D converter. The efficient type A to D converter convert the n-bit analog input into n clock period. It uses a successive approximation register for finding the required value of each bit. The operation is based on approximation tree. The successive stages of approximation is followed on trial and error basis for finding the value of each bit. So the first here the approximation is done in different stage of comparison that is shown in this tree structure. So functional diagram of successive approximation type A to D converter is shown in figure. It consists of start, stop, flip-flop, which is used to control the operation of the converter, a digital to analog converter with a reference voltage, a comparison circuit, and a distribution register. This register is a ring counter which in which a single input is circulating in it. With the start signal SOC, there is start of conversion. Both control register and distribution register MSB will be settled to 1 and all other bit remain 0. This is the first stage of comparison. Now the output of control register is 1000 for a 4-bit ADC is given to the DAC. The DAC creates a reference voltage with which analog input voltage is compared. VA greater than or equal to V reference, the output of comparator is 1. VA less than or equal to V reference, the output of the comparator is 0. When comparator output is 1, the current bit is fixed with 1 and second bit from MSB of control register is introduced with 1 more 1. So 1100 for a 4-bit ADC and then second stage of comparison will be started. When the comparator output is 0, the current bit is fixed with 0 and the second bit from MSB of control register is introduced with 0. So 0, 1, 0, 0 for a 4-bit ADC and then second stage of comparison will be started. The result of first stage will alter the distribution register content as the second bit from the MSB to be 1 and all other bits to be 0. The A to D conversion depends on the conversion period T and number of bits n. It is given by Tc equal to T into n plus 1. C is the conversion time, T is the clock period, n is the number of bits. On the other hand, the distribution register content will vary with circulating 1 depending on stage of comparison, that is 1000 for first stage of comparison and 0100 for second stage, and likewise when the comparison reaches the last stage, the LSB of distribution register will be 1 with all other bits remain 0. Control register content will give out the digital output for input analog value. The stage by state control register content and the correct output is tabulated 8-bit digital output. So this one is the tabulation for the successive approximation type analog to digital converter. When the LSB of distribution register is set to 1, the conversion is finished. This 1 is used to trigger the stop flip-flop by the end of conversion pulse. The stop flip-flop will stop all the conversion process and reset at the register content. Advantages: output accuracy is high. The converter size can be increased by increasing the register size. Single slope type ADC. It utilizes the digital counter technique to measure the time required for a voltage ramp to rise from 0 to input analog voltage level. The ramp may be negative ramp also. The time required is measured between input analog level to 0. They consider a positive going ramp when the input analog voltage is equal to ground voltage or 0. The ground comparator will give a start signal to the gate. The gate allows the clock pulse from the crystal oscillator to the binary counter. During the counting is going on, when the ramp voltage is equal to the input analog voltage level of the input comparator, the comparator will produce a stop signal to the gate, which stops the clock input to counter, hence counting is prevented. Counter value is a function of input analog voltage. By suitable scaling, the counter value may be made equal to the input analog value. So the single slope A to D converter is shown in figure. Advantages: conversion process is simple. Disadvantage: the time needed for stabilization to new value is proportional to the rate of change of input analog voltages. So possible question: what's the signal to noise ratio of an ideal 10-bit A to D converter? That is 61.96 dB. Thank you.